Now left this f of 2 we got 4k, and right hand limit, that is a 3. So right hand limit equal to right hand limit of 2 is equal to f of 2. So this and this equal, so we will get the value of k. So 3 is equal to right hand limit, that is 3, and the f of 2 is 4k. 4k, we need the value of k, that is 4k is equal to 3, k is equal to 3 by 4. Question number 28. F of x is equal to kx plus 1 if x less than equal to pi, cos x if x greater than pi, at x equal to pi. Means f of this function is continuous at x equal to 5. So find the value of k. Question number 28. The given function, that is f of x is equal to k x plus 1 if x less than pi, that is cos x if x greater than pi. So for equal to, we are going to take the function this one, and for greater than this one, so left hand is not required. We need the right hand and we need the f of function. So it is continuous at pi. Continuous at x equal to pi. So therefore left hand limit x tends to pi minus f of x is equal to limit x tends to pi plus f of x is equal to f of pi. So we have the left hand, left will be this function and right will be this function, and f of pi will be this function. So f of pi at x equal to pi, f of x is equal to, that is k x plus 1. So we need f of pi, so it will, instead of x, it will be replaced by pi, k pi plus 1. Now left hand limit or right hand limit. See, if we take the left hand limit, here we have the constant. So constant and constant, it's an own work. So I need a without constant. So take the right hand side. If you take the right hand side, so here there is no constant, so we will get a value of k. So I am taking this 2. So for the right hand limit x tends to pi plus, that is f of x. Since it is a right, it will limit x tends to pi plus h. What is the function? Cos x. So equal to limit h tends to 0, it will be cos pi plus h. Now replace it. The h will be replaced by 0. So it will be cos pi plus 0. That is cos pi, 0 plus pi will give the pi, so cos pi. Value of cos pi, that is minus 1. And this are equal. Therefore we got the value of left hand limit or right hand limit, we got minus 1, and the f of pi will go k pi plus 1. So we can write k pi plus 1 equal to minus 1. Take the minus 1 that side. So k pi is equal to minus 1. If a plus will become minus. So k pi is equal to minus 2. That is k is equal to minus 2 by pi. So this is the required question. This is the required value of k. Question number 29. Question number 29. F of x is equal to kx plus 1, comma, if x less than equal to 5, 3x minus 5 if x greater than 5 at x equal to 5. This is the f of x, this is the function, this is continuous at 5. So find the value of k. Question number 29. So f of x is equal to kx plus 1 if x less than equal to 5, 3x minus 5 if x greater than 5. continuous at x equal to 5. So it will be limit x tends to 5 minus f of x is equal to limit x tends to 5 plus f of x equal to f of 5. Which one? F of 5 will be get here. Okay, f of right hand limit will be function, so we are going to take this two. Also at x equal to 5, the function is f of x is equal to kx plus 1. So f of 5, it will give k5 plus 1, that is 5k plus 1. So now right hand limit, limit x tends to 5 plus f of x. We can deal without considering the h also, because there is no trigonometric function. Limit x tends to 5 plus the function is when it is greater than, so it will be greater than. So this is the greater than 3x minus 5. If x greater than 5, so this will be the function 3x minus 5. So now instead of x, it will be 3 into 5 minus 5. 3 5s are 15 minus 5, that is equal to 10. So this and this will be equal. Therefore 5k plus 1, because put the value of here, value of this, and put the value of this. So it will be 5k equal to 10. So 5k is equal to 10 minus 1, that is 9. 5k is equal to 9. K is equal to 9 by 5. So this is the required value of k when the function is continuous at 5. This is the value of k. Question number 30. Find the value of a and b such that the function defined by f of x equal to 5 if x less than equal to 2, ax plus b if x greater than 2 and x less than 10, 21 if x greater than equal to 10 is a continuous function. So this is a continuous function. Where is this is continuous function? This is continuous at x equal to 2 and x equal to 10. From here we have to find the value of a and b. There is a question. Also question number 30. Question number 30. F of x is equal to 5 if x less than equal to 2, ax plus b if x greater than 2 and less than 10, and 21 if x greater than equal to 10. So it is continuous at f is continuous at x equal to 2 and x equal to 10. So first at x equal to 2. Since it is a continuous, limit x tends to 2 minus f of x is equal to limit x tends to 2 plus f of x is equal to f of 2. So f of 2, this will be the function, f of 2, this will be the function, and f left hand limit will be this will be the function. So I need the unknown, we need the unknown. So this will we have to take the function f right hand limit greater than 2, because then only we are going to get this one. So 1 will be the f of 2, the function. So this we have to solve for this 2. So now f of 2, so at x equal to 2, the function is f of x is equal to, that is 5, this is greater equal to 2, so this is a function. And if we put the value of f of 2, since it is a constant, it will remain a constant, so 5. Now right hand limit x tends to 2 plus f of x is equal to limit x tends to 2 plus our right hand limit, so this is ax plus b. So instead of x, it will be now instead of x it will be 2, so 2a plus b. So these two are equal, therefore 2a plus b equal to 5. One equation we got. Now again we have to find another equation using the now at continuous at x equal to 10. So here also limit x tends to 10 minus the f of x is equal to limit x tends to 10 plus f of x equal to f of 10. Which one we are going to take? One will get the value and one will be that will be with the unknown. So when it's greater than, we can go for the greater than and f of greater than 10 means right hand limit will give 21 and f of 10 will give 21. So take the f of 10 and we need here, we need the unknown, one unknown. So two unknown we need it, so you have to go for the left hand limit. So here we need the left hand limit and the f of 10. So we need this one because all these three are equal. We need this one and this one. So at x equal to 10, f of x is equal to 21 implies f of 10 will give 21. So now right hand limit, we need a left hand limit. So left hand limit, this is the function. So limit x tends to 2 minus 10 minus f of x, so less than 10. So this is the function limit x tends to 10 minus, that is ax plus b. Now instead of x you will put 10, so it will be 10a plus b. So this is the equation. Since these two are equal, therefore 10a plus b equal to 21. So this is the equation 1 and this is the equation 2. So we can go for 2 minus 1. 2 minus 1 also correct, 1 minus 2 also correct. So 2 minus 1, 10, this is 10a plus b equal to 21. So this is 2a plus b equal to 5 divided by minus, since it is a minus the sign will change. So it will give 0, 10 minus 2, that is 8a equal to 21 minus 5, that is 16. So we know that 16 2s are 8, so a equal to 8. Now put this, we got the value of a, put the value of a in equation 1. Put the value of a in equation 1. You can put it in equation either in the equation 1 or either in the equation 2. If you put in the equation 1, the calculation will be small, so to put it in the equation 1. If you put in the equation 2, there also will get the result, but it will be time consuming because number are bigger, so that for while calculating it will require the time. So go with the equation number 1. So putting the value of a, putting a equal to 8 in equation 1. So this is the equation 2a plus b equal to 5. So a is how much? A is 8. So 2 into 8 plus b equal to 5. So 8 2s are, no, value of a is 2. A is equal to 2. So it will be 2a plus b equal to 5. So that is 2 into 2 plus b equal to 5. So 4 plus b equal to 5, that is 4 minus b equal to 5 minus 4, that is equal to 1. So therefore a is equal to 2 and b is equal to 1. So this is the value of a and b when the function is continuous at x equal to 2 and x equal to 10. The value of a is 2 and b is minus 1, b is 1. Question number 31. Show that the function defined by f of x is equal to cos x square is a continuous function. We have to show that this f of x is continuous function. This will be solved by the composite function. So here the function, we are going to consider two functions. Question number 31. Question number 31. It is given that f of x is equal to cos x square. So we are going to solve by the composite function. Means if we are going to here we have to choose two function. If this two function is continuous, then this function will be continuous. So here we have the there are two functions. One is a cos is trigonometric function is continuous, and this is algebraic function x square is a algebraic function, because this function is algebraic function is continuous. So we have to consider as this one, let's consider as gx, and this is hx. So gx will give cos x and hx will be x square. So both are continuous, therefore g of hx will give, that is cos g hx. So it will be cos hx will be how much? That is x square. Now g is the cos, so it will give cos x square. G of x and hx are continuous. G of x and h of x are continuous function for all x belongs to R. Therefore, because we have f of x is equal to g of hx is also continuous function for all x belongs to R. Now for question number 32. Question number 32, it is also same. Here it is given modulus hx, modulus cos x. So the question number 32, we have to show that f of x is equal to cos x. The question is show that the function defined by f of x is equal to cos x is a continuous function. So here also we have two function. One is a modulus, one is a trigonometric. Here we have two function, one is modulus and one is trigonometrics. So we are going to consider the first one, that is g of x as a modulus, that is modulus x, and hx as a continuous cos x. So f of x, so it will be this and this, g of hx. So g will be as it is, hx is how much? Cos x. Now g of cos x, so g is modulus, so it will go inside, so it will be cos x. So therefore gx is continuous because modulus function is continuous and trigonometric function is also continuous. So g of x and h of x is continuous function, for all x belongs to R. Therefore f of x is equal to g of h is also continuous function for all x belongs to R. So 33, examined that sine modulus x is continuous function. So here f of x is assigned modulus x. So f of x, so here we are going to go by composite functions. sin x and a modulus x. Question number 33. So f of x is equal to sin modulus x. So g of x will be sin x and hx will be modulus of x. So g of hx, so it will be g of hx, which hx is modulus x. So g of x is sin x, so sin modulus x. So this is f of x. So sin x are continuous function, f of x and g of x, sin x and modulus x are continuous for all x belongs to R. Therefore, there is f of x is equal to g of hx, also continuous for all x belongs to R. Therefore, sin modulus x is continuous function. Question number 34. Find all the point of discontinuity of f(x) defined by f of x is equal to modulus x minus modulus x plus 1. So we have to find all the point of discontinuity of this function, that is f of x equal to modulus of x minus modulus of x plus 1. Question number 34. F of x is equal to modulus of x minus x plus 1 modulus. So you will have to, this will be gx and hx, gx and hx. So fx equal to g of x minus h of x. So g of x is equal to modulus of x and hx is equal to modulus of x plus 1. First we have to show this is a continuous and this is a continuous, and continuous minus continuous, that is algebraic function, that is when it is a continuous function substitute continuous function, it will give the continuous function. First we have to make the function. What is the modulus function? We have to write the modulus function, that is gx is equal to minus x when x greater than x less than 0 and x when x greater than equal to 0. We have to show now this is a continuous. So at x equal to 0, the function is f of x greater than equal to and greater than, that is x. So f of 0 will give how much? Put it in 0. Now right hand limit and left hand limit. Limit x tends to 0 minus f of x is equal to limit x tends to 0 minus left hand limit. So that is minus x. If we put the minus 0, it will remain 0. Right hand limit x tends to 0 plus f of x is equal to limit x tends to 0 plus the function is x. So it will be 0. These three are equal, so it is a continuous. So it will be g of x. Here is a function of g. It will be g of x, not f of x. G of x. So it will be limit x tends to 0 minus g of x is equal to limit x tends to h plus g of x equal to g of 0. So it is continuous at 0. It is continuous at x equal to 0. Now we have to find for the since it is continuous at equal to 0, so it is continuous for all real value. It is continuous for all real value. Now we have to find for the h of x. For h of x, we have to make it function first. So h of x, or this is the, let's see. Therefore f of x it's complete. Now for the h of x, that is h of x is equal to h of x is equal to, that is modulus x plus 1. We have to use the modulus function. So h of x is equal to, it will be minus x plus 1 when if x plus 1 less than 0 and x plus 1 if x plus 1 greater than 0. Now we have to take this. And so h of x is equal to, this will as it is, if take the one that side, it will give minus 1 x minus 1 x plus 1 if take it that side x greater than minus 1. So we have to check it at x equal to 1, at x equal to minus 1. So which one will the function, this is greater than equal to, so the function will be f of x, not f of x, h of x, h of x equal to x plus 1. So it will be plus we need f of minus g 8 h of minus 1, h of minus 1, that will give here minus 1 plus 1, so that is 0. Now left hand limit x tends to minus 1 minus, because minus 1 left hand limit f h x, which one is the limit x tends to minus 1 minus h x less than, so this is the less than, minus bracket x plus 1 equal to, it will be minus, give it will be how much, minus 1 plus 1, so it will be 0. Minus 0 is equal to, minus 0 is equal to 0. Right hand limit h tends x tends to minus 1 plus h x is equal to limit x tends to minus 1 plus, so this is greater than right hand limit, so this is greater than minus 1, so this will the function, that is x plus 1. Instead of x, it will give minus 1 plus 1, that is equal to 0. All these three functions are equal, that is limit x tends to minus 1 minus f of not f, h of x is equal to limit x tends to minus 1 plus h of x is equal to h of minus 1. So it is a continuous function, it is continuous for all real value, it is continuous, NOUS, continuous for all real value. So it is a continuous. So we got both are continuous. We have how much? That is f of x is equal to g of x minus h of x. This is also continuous, this is also continuous. So continuous function minus continuous function, continuous function minus continuous function, continuous function minus continuous function, so it will give continuous function, therefore fx is continuous, therefore f of is continuous for all, continuous for real value, is continuous continuous for real value. Fx is continuous for real value. Since both are continuous, it gives the continuous. So therefore fx is continuous for real value.